As soon as you see the word motion, that's what tells you it's temperature. Okay? Now, how do we know which object would have the greatest heat or thermal energy? Okay, either answer is fine. Okay, I heard mass, which is fine. I heard size, which is fine. Either answer is good. Okay, mass and size. Things that are more massive have more heat. Things that have a bigger size have more heat. So now looking at the two cups that I've put down there, I've given mass and I've given temperature. Which one has the greater motion? What do you look at to figure out motion? That's why I gave you questions 2 and 3 to hopefully help you figure out question 4. So when you look at question 3, all right, and question 2, they should help us answer question 4. So greatest motion. What tells us greatest motion? The temperature. So which one of those cups has the greatest motion?
50 cup each.
That's right. The 50 degrees right here. All right. The 50 degrees tells us we have the greatest motion. All right. Because temperature is motion. All right. Which one has the greatest heat?
Cup each.
All right. Why does it have the greatest heat?
Weight.
All right. So it has the greatest heat. Okay, the greatest size has the greatest heat. All right, what information does specific heat tell us? What does specific heat tell us? Unless you looked in your notes, most of you probably don't remember. Why do I like to use aluminum foil?
It cools down.
It cools down
Heats up
quicker.
the fastest.
It heats up fast and it
Cools down.
so specific heat tells us what materials heat quickly and cool quickly, or heat slowly or cool slowly. Okay. All right, I have papers, and the top paper has no name on it. All I can tell you is you use blue, brown, and purple. Looks like this on the back. Look like anybody's? Is it yours?
So I didn't get a check off.
All right. Everybody have a paper? Who doesn't have one? Other than Virginia, who was absent, did y'all keep y'all's? Or were y'all just absent on Friday? I swear y'all were here.
I ain't get one.
You didn't get one Friday?
No, I didn't come.
Oh, you weren't here Friday? That was good, you left on. Not here Friday, but. You weren't here either? So everybody has a paper now. All right, the colored pencils are still on the back table. All right. Most of you, from what I can tell, drew most of the graphs on the questions. We're still working in groups of 2. Not groups of 4, not groups of 8, groups of 2. All right, so finish your graph. And my 4 people I just handed them to, so Mr. East, Vince, Chase, and Virginia, you 4 pair up in groups of 2.
Oh, this thing cold.
No heat on in here. Didn't we cover that a while ago?
Y'all was the junkie down there to A like one I couldn't think look at the damn one. Right, it's straight and it has all the
Hang on, get my phone.
Where is it?
look at the color. Yeah, what?
Take the best.
Look at me.
Let me make it. Forgot it.
That would be good.
Yeah.
No, that's everybody thinks that's my name. What y'all think? It has the best temperature and also the best. Look at it. Time to look at all these. I don't know the time, but you get what I'm saying. I don't know if it's like that reason why though. I really don't. I just know that it's like who was the shortest one to this? In specific heat is I don't know.
You get it?
I forgot that I plugged it up.
So 0.
Like for insulin A, I did black, and it's time again, and it's big.
What
So like,
which one?
no, like, line is
Orange.
and then see, I get
Oh, cause the line. Okay. So it was. I'm writing in pen. Oh my gosh. I lost my roots. I lost all the pictures. I ain't have to Jesus ain't playing
Because
I was like, on the ground, the lines, because you know you'll be like, on the ground, the lines. I'm gonna say on the ground, my day, I'm gonna it's like a bee
and then what's next side?
have like almost a constant
Was it hairy?
heat. I don't know.
I said hairy, I said.
Yeah. Yeah, or it keeps the heat in the basket. This is, yeah.
No, he's saying keep that. He's a thing that keeps the.
It can keep the heat away or it can keep the heat in, depends on how you look at it. In your case, y'all are keeping the heat in.
I know he did.
I went real. Y'all think insulator?
What are we talking about in the other? Let's talk
I'm
about it.
thinking that
Look it up in the notes.
insulator is like fuck.
I'm not telling you.
Let's
what it
think
is.
about insulated shit in the house. When it's cold, you want them to do keep it warm. Like in my life, you want them to I think that it's gonna be this shit. When it's hot,
I'm right with you over there.
cold.
Ray, watch your language.
I mean, look at this stuff over here.
Okay, make sure you say the stuff.
Yeah. So you feel me? Because why would it be blue? That don't even make sense. It would be blue. We know it's not purple. Well, this is my color. We know it's not purple. So it's only one color. What we do? I mean, oh God, man.
So why do you use it to get something?
Hold up. This shit almost the same. Orange and blue. I'm trying to figure out the differences.
What is that coffee cup? Pour coffee in and keep it. Where's the coffee? The coffee. Pour coffee in and keep it.
I'm breathing. I'm
It's up,
breathing.
like what's that name?
And then best and stuff. Imagine the best. 30 minutes. Okay. Use the material. Please. This is 30 minutes. So. Hold up, wait a second. Most definitely. 1998. A is 8076. And this one is 908076. Right, look, because it's a lot. Instead of being the highest, we got that right. So instead of C, because look at it, it's 180, 70. Like, what a 90 is. Let's get the whole number. They both compensate. What y'all think? What y'all think? Y'all think it's for the age best? Because I could be wrong. I don't know. I could sound what you think? It's like being the best. 199.
You got to make it.
It's been like, it's like a single bit.
How do you think?
This one is these specific, just be simple. So, the order now. That's the best. It's a whole. Ms. Wall, I have questions. Okay, so we're saying. Yeah, we trying to figure out which is the high specifically. No, we want this first.
One specific heat.
Well, cool, heat. Cool heat. It's a
Like aluminum foil. Aluminum foil means it goes what? Aluminum foil cools faster. So whoever has the smallest specific heat cools faster. You're looking at these to see who cools faster. That would have the lowest specific heat. Whoever cools the slowest has the highest specific heat.
Oh, okay, y'all. Whatever cools. We got this right. This is the highest specific. These are specific. But we trying to figure out. You know, in our adult schools, Cause I know what we're talking about. I did. I got so many I see y'all tonight. Let's do something nice. About
How do we have you?
Here we go. specific heat. That's what this one. This one. Which one? Oh, your nose is currently to the back. But it's specific heat. Okay, y'all. Okay, the heat requires the raw temperature of the unit man's Maya, where did you get yours? I love it. Okay, so some hospitals have different specific heat cools. So water cools slowly, hot cools very rapidly. So it's like how room will cool the heat real quick. That's what it's basically saying. Like which one cools it? So the highest specific heat will be the one that slower. So we got it's let it be right.
You really can't tell 1236 and that there's
It's letter A. The best insulator is one of the cool, like aluminum. And it cools serious. So which one cool the best?
What are you telling them we didn't learn about?
Oh, we didn't learn this already? I wasn't even paying attention to be honest.
Yes, we learned about it Friday. Why on earth would I give you the assignment I didn't teach?
You can be serious.
Why would I give you the assignment?
I just told you I wasn't even paying attention.
That's the problem, and that's why I'm upset.
I'm doing text correction today because no, that's not an A and it's
I will disagree with it. Virginia, what are you asking them? They're telling you they weren't listening to?
She is like, I figure out I wouldn't know what to do. I feel like she's like where'd you do that? I didn't check to see what makes the most bad.
Are we talking about the insulator or something?
Like, which insulator makes, which material makes the best insulation?
What's the point of an insulator?
To insulate.
To keep the heat in or out? For most part, if it's a hot material, you want to keep the heat in, right? So which one of those keeps the heat in? Stays the hottest. That's what you're supposed to be looking at.
Okay.
The rest of y'all hear that?
We want the one that keeps it hottest.
If you're looking at for which one's the best insulator,
Right, it'll be insulator B. I thought we was right too. That's what she said. Wow. Hold up, this is Ken. She got me. No, come on. No, there's a group. Come on, no, just come on, no. This. We got the truth thing. We need facts, okay? We need. Oh, we confused.
where you confused at?
Okay, so we're talking about on the side. Let's look at this.
That's right, it's what it means.
For the first one, back to the thinking table. This is too much, okay?
Which one is the greatest insulator and which one has the best specific heat? Might not be the same. They could be the same one.
They could be the same.
They could be the same.
So what's that? Okay. For this one, is that a good like?
How do you know that? What?
Then that's what you tell me. Yeah. Or there's,
I just want to know if it's like, it's 4 minutes later, B, 2 minutes later, B. We already know which one that insulated A makes it go.
I mean, all that.
The one that's keeping it the highest insulated B, so they got to. Man, I thought you were gonna say because it's keeping shit cold. I thought you was talking about us. I'm like, girl.
I don't know.
I thought you were saying it's already worked out, but I'm thinking that it's like a beat down. You're saying what keeps it the warm, and this temperature is not dropping. Oh, for 3, I said it isn't keeping anything warm because the temperature is dropping. Period. That should drop. That shit is not dropping. Well, everything is dropping. You get what I'm saying? It's dropping bar. I can't explain it.
So you're saying, yeah, but they are out there. That's
That's what I'm saying. You're saying all of them have the same.
You don't want to hear it.
Right, it's not.
Okay, so I'm saying. I want to mark out all this not just road. That's right back to it's like right. So yeah, I think it's like
It's specific.
no, it's not. It's specific.
SPECIFIC. Specific.
But this is explained in terms of direction.
You pass the ball back and forth.
So whenever we go. They have to have.
Alright, well, I'm looking at the TV and
I'm not saying he's a good striker, I'm just saying he has
He has missed some of those touches.
Yes.
Like almost.
I'm gonna say because it's a key conductor.
Wherever they.
I'm good because it's a key conductor and it isn't dropping drastically.
You got 5 minutes, then you need to have them up here on my desk.
No, when you're finished, it's done.
I didn't know how to spell drastically, so serious.
Talking about.
Thank you, girl. Okay, so now we still got all of them.
Oh, well, that's I'm not
Right, you say he did, baby, he's expensive. That's nice. It's cold outside and he was inside. Oh, yeah, he go out. He flow from, Mexico, so it go out.
What are you recording? Sit, type it in.
He would travel. Waste. Oh my gosh. We're trying to keep cold air in and not let the heat in. The heat comes in.
If you're gonna get a few,
You're trying to keep the cold air in. Okay, you could make a rule to answer the following questions. I had to You don't have a whole paper on so something like this. I This one only, no, it doesn't. I know that the higher the temperature, the more mass, right? The more motion. And heat is on. Mass is heat, which grams is mass, so that's heat. 500 grams is 70. So yeah. We figured out the grams that way. For which one? We picked this one for the greatest motion. So the greatest motion. It's whatever. Not has the least thermal heat energy. Alright, so yeah, because it's 25, 200 and up on the beach.
He went inside. He told him over there.
So what it is?
That's my new part.
You what?
He's working for Roy.
Oh, you ditched your partner? Interesting.
What we use? Why would that be the least? Oh, okay. I was
Now 1 minute. I told you a little bit ago you had 5 minutes.
I've been doing questions. Now, make sure you have an answer to your so she don't try to. I got 4 more questions.
Yeah, y'all should be done. Yep, that's here on my desk.
Hold on. Never mind. How does that
Temperature is
I
motion.
mean, we got absent people who have finished this thing.
Heat size.
Oh.
Oh, wait, no.
All right.
All right, I need papers coming my way.
Wait, what? What happened?
So I need your papers.
Oh, you do, huh?
Yeah, I do.
Well, could you give us like 30 seconds?
I'm
Like
not feeling
30
it.
seconds? Like 1, 2, 3, 3.
Back further. Raul, you and Sacramento, come up here. Y'all been talking soccer half the time we've been working, so. No, y'all get more done. Yeah, they work hard up here. Come on, come up here, just one more time.
No.
Thank you. You got more than you needed. Alice, spread these out on my desk. I think we only go through about 21. Spread them out so it's easier for people to pick them up in a little bit.
What was that?
In a few minutes.
Oh.
Oh my God.
I don't know what he's talking. What I heard. And I just said,
I'll pull up the class again.
I think I'm either 17 or 18.
I'm 9.
I'll say that.
You're not 9 anymore.
Well-
You changed it.
I am 9.
She changed it, bro.
I did. I fixed some things so that everybody was in here.
I told you.
Okay, we'll see if I'm still 9.
You're not 9. Put it down.
I'm gonna be
23. I want to be 23.
I'm gonna be 8, 9, 10, or 11. 7, 8, 9, 10.
Is anybody there?
There it is, down here. Down here at the bottom.
Like I said, I'm still 9.
You're not. Where you at?
The bottom.
You're not 9, bro.
I'm 10, if I'm not mistaken.
9.
Bro, you're
No,
not
I'm
9, bro.
Mhm. Thank you. You're welcome. What's going on with you?
Jason Witten.
That's what that dollar chopper again.
Somebody done got number two.
Oh, I got 10. You can see it. It's up top. Say number 10.
No.
Please don't. Please don't.
Where she go?
Always. They got to. I mean, I'm the one that's going to win, but I don't think.
All right.
I'm surprised they win the game 7 though.
All right, read the answer. Read the question.
Specific mean.
How specific heat means what? And choose your answer, A, B, C, or D. Oh, they don't have a D on this, A, B, or C. I'm not giving you long. We're going to do about, I don't know, 6 or 7 questions, and then we're going to move on.
Hold up.
Mr. Hernandez, you're going to give me an answer or what? Nope, I didn't. Thank you.
Yeah, that's all I'm confused about.
All right, did I get everybody? All right, so we got 4, 13, and 2. All right, 13 was at least the answer we had the most of. All right, so when we look at it, 13 of us picked the right answer. Unfortunately, 6 of us didn't. Remember, a high specific heat means that you will heat and cool slowly, like water. Water doesn't heat quickly. It doesn't cool quickly either. It's very, very slow. All right, let's pick something else. All right, so got a thermometer and like hot water. Okay, which way does the heat flow? Don't call people stupid. Gotta come back and get Anna Lucy out of there. She wasn't.
Everyone, what number you got?
Did you already give me?
I think so.
The order.
If I've got 19.
23. Is it 23 or 10? Oh, 23.
Yeah, 19 people. So I had 19 I was scanning. All right, where'd my little button go? There it goes.
I got that.
All right, so I like this one.
Very awesome.
That's not what I wanted.
And a little bit, I got a question.
I went away. Where'd it go? We had 19 on 19. But apparently we lost the connection. Everybody had that one right. All right, heat transfer. What kind of heat transfer is taking place there? See if we can not lose our connection this time.
Me too. I was on good conduction because it's there. It's the same kind of
There's water in the box. Wait, which one are we doing
flames
though?
aren't really touching it, guys.
It's only shining.
So what do you worry about the top, the fire or the water in the pot?
Fire. Right, that's what I'm like.
Right. It could be a whole bunch of cold.
Oh, yeah.
All right, I'm missing somebody.
It can't be A. But
That's so. It could probably be.
You
You're changing hands.
I don't have cable.
Hey, it's heated. Oh, yeah, but you can't see the water. So you
All right.
choose. Yeah, let's go.
All right. So why is it radiation? They're not touching the pot. They're below it. Okay? When you look, is the fire touching?
No.
No, that's why it's not conduction. It would be conduction if it was touching. All right? Now, they're trying to illustrate the fire in the pot above it, which is why it's radiation. Now, if they were illustrating the pot of water and showing you the pot, then it would be convection. Okay? That's why it's not convection. All right. So, to illustrate the difference, I know I'm sort of giving you the answer here. Need to edit that good deal. All right. So, what would this one be? Yeah, I did. If you were listening. If I get this wrong, I'm going to be really annoyed.
Don't tell it, Nancy. They picked that or something.
What do you think?
I didn't get yours, John. I got it.
Well, you're a Christian.
All right.
I knew it.
And get Jacobs for Sacramento's.
See what it is, bro.
Jacob. All right. So. All right. So we got 3 people who were not listening to me a minute ago when I said if we just showed boiling water, and it would be what? It'd be convection if we just showed the boiling water. You see the arrows? Whenever they show arrows in something, they're trying to illustrate currents to show you that it is convection. Anytime they have arrows, it's convection. Come on. Oops, let's try that again. I just closed it because it didn't come up. There it is. All right, this should be an easy one.
I don't know this.
I hope this one would be 100. Everybody would get this one. Turn it. There we go. I got it.
Oh, okay.
I don't have Sierra. All right. So the answer is what? Why is it conduction? It's touching. All right. All right. Let's see.
Right.
All right. When a material is heated, the particles do what? When a material is heated, the particles do what?
No. Move.
What do they do when they get heated?
It's A and B the same.
Is A and B the same? No. A is faster, B is they slow down.
D.
D, move faster and get, yeah, A is the same. It's supposed to be, that's supposed to say slow down and get closer together. That's supposed to say slow down. Supposed to be different. It's typed wrong. What's it supposed to say?
Slow down.
Yeah, it's supposed to say slow down and get closer together.
No, it's slow down and move further apart.
Yeah,
Oh, okay.
yeah. It's supposed to be the opposite. It's supposed to say slow down and move farther apart. So let me write that down here. This is supposed to say slow down, move farther apart.
Why do they move farther apart instead of being closer together?
I have to create wrong answers too.
No, I'm saying like, she asked me like, why do we need to be farther apart? Oh.
I'll explain in a second. All right, so we can scan, right? All right, hold up. What do you think the answer is?
Boy.
I dropped it.
You already got me?
I think it is. All right, so we have. All right, so we have 14 people who picked move faster and farther apart, which is right. That's why I said a lot of times when I walk on, I think it was Friday, my fingers will swell. All right, when I walk or I exercise, my particles do what inside my body? They go faster or slower? They go faster, which is A, why I feel hot. And secondly, they move farther apart, which is why I get the sensation that my fingers are swelling and my rings feel tighter. When I sit still like today and I get cold, my fingers get smaller because my particles slow down, they get closer together, I get the sensation that I'm colder, and I can spin my rings around my fingers much easier. Well, I can't right now because I can't wear them. All right, but I could before I hurt my wrist. All right, last one. Oops, let me get rid of this. Last one. Which has more heat? Should be an easy one to end on. All right. All right. So we have 10, 8, and 1. Why is the hot tub the right answer? And not the coffee? It's bigger. Heat is all about size. Okay? Even though the coffee cup is going to be hotter, all right, it's going to have a higher temperature. It's not going to have more heat because it's smaller. Okay? The hot tub is much bigger. All right. If you will, all right, if you will, put your cards back up here on my desk. I need to find that question and edit it before I forget it. All right, find your notes. We're going to finish with some notes today. If I can find that
What do we do this
one.
month? This month, right here. Okay.
Nope, not that one.
I'm trying to play you that day that. So I live more. Not possible. Why did you put 1300? Because I'm trying to get them in order.
You have to put 13 under 14.
All right, there it is. Edit. All right, they slow down and move farther apart. All right, we're gonna hit save. Apparently I don't. I got this done. I hate this new slide. Save just now. Okay, so apparently it's saved. All right. Okay. All right. There, that's fixed. I'll get that to work. Doing that for me? Thank you. All right, we're going to finish with some stuff on phase changes. Clearly, the second half of that board is going to be tomorrow. I took a lot longer on that graphing activity than I thought we would. Now, on the insulator, who should have been the best insulator? Why should B be the best insulator? The temperature stayed the what? Stayed the highest, right? So when you looked at it, insulator A went down to like 50 degrees. Insulator B only went down to like 88 degrees, and I forget what C was. But insulator B stayed the hottest, all right? So what would that tell you about specific heat? Who would, have the highest specific heat? B, because its heat stayed what? The highest. All right, who would have the lowest specific heat? A, because it cooled down the most. Does that mean you got it right over there?
Yes.
Very good.
It took us a minute.
Okay. All right, so we're going to talk about phase changes. Now, we did phase changes, best guess. What y'all talking about it? I'm guessing y'all did it 6th, 7th, and 8th grade with water cycle. Now, I know y'all can tell me about evaporation and condensation.
Yes.
Okay. Did y'all do melting and freezing? Okay. Can you tell me if heat is absorbed or released?
It's
On each of the phase changes.
oh yes.
And can you tell me why?
No. Can't tell you why.
Okay.
have those signs.
All right. Now, most people can tell me evaporation, and they can tell me the opposite is condensation, but they can't tell me anything about whether heat is absorbed or heat is released, much less why. Okay? So that's the new piece in physical science, and we have to draw a graph with it. Okay?
Isn't it released for both?
No, it is not released for both. They're opposites of each other. So one releases and one absorbs. Okay? Evaporation is going to do what?
Release. It's releasing.
That's what I'm asking, because you're second guessing yourself.
No, it's releasing.
Okay, let's see if we're right. All right. So, and it doesn't matter which one we do first. We can do either one. We can do evaporation and condensation today. Typically, I do melting and freezing, but we'll do that one. All right. So first of all, what is a phase? Anybody know? It's another word for a state of matter. So what are the states that we're going to talk about? Yes. Okay? So we're going to talk about solids, liquids, and gases. Those are the three states we're going to talk about. Solids, liquids, and gases. Okay? Now, because we're going to talk about a phase change, what's a phase change going to be? We're going to change from what to what? Sure. All right. Okay. So we're going to change from one state to another. Okay. We're going to change from one state to another. So, as an example, I heard some solids to liquids. I heard liquids to gas. Any of those are good. Okay? They're all good examples. And we'll talk about others. Now, there are actually 6 state changes, but your curriculum only wants you to know 4. So we're only going to talk about 4. So if any of you remember talking about sublimation in middle school, or the opposite of sublimation is deposition, we're not responsible for those 2 in physical science, so we're not going to talk about it. Okay, sublimation is changing directly from a solid to a gas. like dry ice is solid carbon dioxide. It changes from the solid directly to a gas. It's not part of our curriculum, so we're gonna skip that. Okay? Now, what is needed for a phase change to occur? This is the part that most students have the hardest time grasping about a phase change. Alright? This is the piece that students struggle with, that I cannot get across. It doesn't matter how many years I've taught it, I can't do it. Okay? Heat has to be absorbed or released. What do you suppose students tell me when I ask what is needed for a phase change to occur?
Heat needs to heat. I don't know.
Nope. What do you think they pick in the multiple choice answers, or they write down and tell me?
Absorbed.
Nope, it has nothing to do with heat. They tell me what, Prashant? I can't hear you. Say it louder. Be brave.
I got you.
Tell William and he'll say it.
Transition.
Nope. Has to do with the opposite of heat.
Cold.
Not quite that opposite. What's the other word we use interchangeably?
Thermal.
Starts with a T, but it's not thermal. It's the word people confuse with it all the time.
Temperature.
Temperature. What do you think they tell me about temperature?
Temperature needs to be absorbed.
Don't use the word absorb to release.
Oh.
If I could get that across, we'd be home
It
free.
needs a temperature.
It needs a temperature what?
High temperature. They need a high temperature.
The temperature has to do what?
Change.
Has to change. Okay? That's the thing people tell me, and it's wrong. Alright? In order for a phase change to occur, temperature doesn't change at all. Temperature stays the same. Heat is absorbed or released. Okay? This is the piece that everybody gets wrong all the time. T with a degree symbol is temperature. Temperature stays the same. You're going to hear me say this tomorrow. No, y'all are testing tomorrow. On Wednesday, like 400 times. By the way, y'all's test on temperature or on heat and energy is Friday. All right? Temperature stays the same. It doesn't change. Heat changes. So, when ice melts, can anybody tell me what temperature ice freezes at? The temperature water has to be for ice to change or water to change in ice. Anybody know? I'll take it Celsius or Fahrenheit. I'm not picky.
32 degrees.
32 degrees is on what scale?
Fahrenheit.
That's on Fahrenheit. Anybody know the Celsius?
100. Is it in the hundreds? That's 70. 20 something. I don't know how to tell something.
Okay. Water changes into ice at 32 degrees Fahrenheit or 0 degrees Celsius. Now, ice changes back into water at what temperature? What do you notice? Temperature doesn't change. Okay? Temperature stays the same. Okay? The only thing that changes is heat. The heat changes. That's the piece that we've got to learn on Wednesday. How does the heat change? 2 of the processes absorb, 2 of the processes release. Okay? Now, if you absorb heat, you might remember this from biology class, you're endothermic. If you release heat, you're called what? Exothermic. Now, and I've got a small lab to go with that. I think we can get to it on Wednesday, if we can't, we'll do it very early Thursday. Now, your only homework is to do what?
Study.
Study for the benchmark if you feel so inclined.
Tomorrow.
Heat is not on the benchmark. Your benchmark goes through energy.